MP4 TV. The world is thinking.
Quantum computers you're talking about. Yeah, I mean, what I want to actually say is that I lied to you, and that quantum theory is not a theory of microscopic objects. It's not a theory of small things. It's actually a theory of isolated things. And it's because it's possible to isolate something small like an atom from its surroundings that it behaves in this bizarre manner. But in principle, if we could isolate Fred from his surroundings, at the moment there are air molecules bouncing off him, there's photons of light bouncing off. If we could put him in a vacuum chamber, and we could
do it all the time.
Yeah, and we could completely isolate him from his surroundings, he would behave like a quantum object. He would be able to go through two doors simultaneously and do all these incredible things. And that's, of course, that's what a quantum computer is. I mean, it's an attempt to build something big that is quantum, to exploit the ability of an atom to be in many places at once, to do many calculations at once. And a quantum computer could massively outperform the fastest supercomputers we've got today. But the problem in building these things is they have to be isolated. You've got to build a big thing that's completely isolated from its surroundings. So they're being built, you know, in vacuum chambers, and they're cooled to minus 270 degrees, all this kind of stuff. But there's currently a race on in the world, you know, between militaries, and I don't know if you're building a quantum computer, are you?
We're doing things like that, you know.
Yeah, universities, governments to try and build a quantum computer.
Yeah, no,
so we will have one on a desktop within, you know, maybe 20 years. Currently, we've got kind of primitive quantum computers, and the biggest can manipulate something like about 10 binary bits.
Yes.
I mean, your computer at home can manipulate billions of bits, so they're very primitive. But they're not only a practical nuts and bolts device that you can put on a tabletop that behaves like a quantum object, but they have profound kind of philosophical implications for the nature of reality. Because it's very easy to imagine building a quantum computer within maybe 20 years that can do more calculations simultaneously than there are particles in the universe.
Yes, that's right.
And then you have to ask yourself, where is the quantum computer doing the calculations? I mean, your computer can only do, you know, it can store a number of a particular size because it's got the memory space. Where is the quantum computer doing the calculations if it's using more physical resources than exist in our universe? And David Deutsch, who's a physicist at the University of Oxford, says that what the quantum computer does is exploits parallel realities. It exploits copies of itself in parallel universes. So, when you set a quantum computer a problem, it splits into multiple copies of itself in parallel realities. They all work on threads of the calculation, and they come back together again with the answer. So he says the quantum computer is something entirely new under the sun. It's the first thing we've ever invented that exploits parallel universes.
If parallel universes exist.
If they exist. I mean, you see, the interpretation of that double slit, you know, the double slit experiment, where a photon appears to go through two slits at once. I mean, there are 13 possible interpretations of quantum theory. And one of them is what we call the many worlds. So we explain the fact that the photon, you know, the photons appear to mingle with each other by saying that the photon goes through one of the slits and it mingles with another photon that went through the other slit in a parallel reality. And that's one possible explanation, and actually it's embraced by a sizable minority of physicists, you know, 50 years after it was suggested. So we face two possibilities. Either these parallel universes exist, or the universe behaves as if they exist. And I think most physicists would say, you know, the universe behaves as if they exist. But, you know, I don't know which one you'd like to pick, you know.